Look into this absolute space. There is no width, no depth, and no height. It is a mathematically perfect void, and it serves as the necessary blank canvas for all physical architecture. This animated diagram shows a single point, labeled A. A point dictates an exact location in space, but it possesses absolutely zero size. It is a zero-dimensional, or 0D, entity. If we pull point A outward continuing directions, we create a one-dimensional line. Extending to infinity on both sides, it has no end, making it impossible to measure or use directly for physical construction. To build something real, we have to isolate a piece of that infinity. By chopping the line, we create a line segment. It is bounded by two fixed endpoints, P and Q, giving it a distinct, measurable length, like 5 centimeters. We can also create a hybrid shape. If we keep the starting anchor point P locked in place, but allow the other end to shoot off infinitely in one direction, we get a ray. This diagram shows what happens when two distinct rays originate from the exact same anchor. That shared anchor is called a vertex, and the open gap between the rays forms an angle. Angles scale in size based on the rotation of these rays. When the gap is narrow, measuring anything less than 90 degrees, it is an acute angle. When that top ray snaps into a perfectly vertical position, the geometry locks into a right angle. It forms a rigid 90-degree foundational corner. As the rotation continues, the mathematics shift. Expanding past 90 degrees gives us an obtuse angle. Hitting a perfectly flat line creates a straight angle at 180 degrees. Dipping below that horizon forms a reflex angle until the sweep finishes a complete 360-degree circle, known as a complete angle. This diagram shows two separate angles, one at 60 degrees, the other at 30. When they lock together to form a perfect 90-degree corner, they form a predictable pair known as complementary angles. If adjacent angles combine to create a completely flat 180-degree horizon, they form a linear pair. In geometry, angles that total exactly 180 degrees are called supplementary angles. This predictability holds true even when solid lines crash entirely through one another. Look at the opposite quadrants of this intersection. The top and bottom spaces match perfectly, just like the left and right spaces. We call these vertically opposite angles, and they guarantee that opposing corners share the exact same measurement. Lines do not always intersect. Some exist in the same plane but travel endlessly without ever touching. These are parallel lines. This diagram shows the defining trait of parallel lines. As the markers slide back and forth, the gap remains eternally equidistant. The numerical distance between the tracks is identical at every single point. We disrupt that stable parallel grid by introducing a transversal. This is a single line that strikes completely through two or more existing lines. That single diagonal strike immediately generates 8 distinct angular zones across the two intersection points. If we dim the outer geometry, a hidden pattern emerges. The interior parallel tracks and the transversal form a bold Z shape. Look at the opposing inside corners. These are alternate interior angles. Here, these alternating corners will always possess the exact same measurement. The infinitely complex architecture around us is ultimately just the inevitable, perfectly balanced expansion of a single starting point, a location with absolute precision and zero physical dimensions.